An audio amplifier is one example of an IC. You can use audio amps to increase the power of an audio signal. For example, if you have a microphone, its small output signal is fed through an audio amplifier to make a strong enough signal to power a speaker. Another type of IC used in electronics projects is a microcontroller, a type of integrated circuit that you can actually program to control cool gadgets like robots. We discuss microcontrollers in more detail in Chapter 13. Sensing with sensors. Certain electrical components generate a current when you expose them to light or sound. You can use the current generated together with a few of the components listed in the previous sections that control electricity to turn on or off electronic devices such as light bulbs or speakers. Motion decorators, light sensors, microphones, and temperature sensors all generate an electrical signal in response to stimulus, motion, light, sound, or temperature, respectively. These signals can then be used to turn other things on or off. A high signal level might turn something on, and a low signal level turn something off. For example, when a salesperson walks up to your house, a motion detector can turn on a light, or better yet, sound a general alarm. These signals take different forms depending on the components supplying them. For example, a microphone supplies an AC signal, and a temperature sensor supplies a DC signal. Figure 1 of 1 shows diagrams of a few signals that you run into often when working with electronics. These signals include a 5 voltage DC signal, a high input, 0 volt DC signal, a low input, 0 to 5 volt DC square wave, the output of an oscillator, a device that cycles between high and low voltage. If you use this signal as an input to a light bulb, it causes the light to blink on and off. Negative volt or positive volt. AC sine wave, a signal such as a microphone that generate alternating currents that a device such as an amplifier uses to input. A microphone generates the waveform in Figure 1.1 when it receives the sound produced by turning fork. Notice in Figure 1.1 that the transition from 5 volts to positive 5 volts to negative 5 volts are gradual for the sine wave and more abrupt with the square wave. You can find out more about various types of sensors in Chapter 5. Powering up. Electricity can power electrical components to produce light, heat, sound, motion, and more. For example, an electric current supplied to a DC motor causes the shaft of the motor to rotate along with anything you've attached to that shaft. You can power speakers, light bulbs, LEDs, and motors with electricity. If you want to read more about these types of components, check out Chapters 4 and 5. How electricity becomes electronics. When you need to use electricity to make something work, such as a boombox, you've entered the world of electronic gadgets. No doubt you're eager to start making your own electric gadgets. We cover the basics of how electronics and gadgets interact in the following section. Creating a simple circuit. Take a battery, a resistor, an LED, and some wires. Put them together, and you have a simple electronic circuit. That's all an electronic circuit is. Wires connecting components so that a current can flow through the components and back to the source. Figure 1.2 shows a simple circuit. You can place the parts in the circuit, also called components, on something called a breadboard and connect those parts with wires. If you've ever played with Mr. Potato Head, you understand the principles of a breadboard. You stick things in the point, the potato, ears, a head, eyes, and so on to form a potato person. In the same way, a breadboard has slots for you to insert electronic components to build a sample circuit. If you're really happy with what you've created, you can then use that design to get a printed circuit board made. See Chapter 11 for more information on building circuits on breadboards. Figure 1.2 shows wires connecting to both terminals of the battery. In this circuit, this connection allows the current to flow from the battery through the LED and other components and back to the battery to complete the circuit. You can also complete the circuit by connecting parts of the circuit to the metal chassis of a gadget, such as the metal housing of a stereo. We call this circuit ground, may or may not be. We call this connection a ground because it is used to reference for all voltages in the circuit. Ground may or may not be connected to the actual earth, but it is always the reference from which you measure all other voltages. We discussed grounding in detail in Chapter 6. You can represent a circuit as a schematic. A schematic is just a drawing showing how components are connected together by wires. Check out the schematic for the circuit in Figure 1.2 and Figure 1.3. You can go for Chapter 6 for more schematics. Figure 1.3, can you decipher the schematic of the circuit shown in Figure 1.2? Deciding to build. If you're itching to build a simple circuit to try out your skills, you can find several circuits in Chapter 14. For example, you can create a breadboard circuit that sounds an alarm when someone turns on the lights in your room. Building these projects is a fun way to get familiar with how to put together circuits. But don't jump right into projects if you're a beginner. Not until you read through a few.